Section 10.6, finding segment lengths in circles. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. Sounds like a movie title, a very bad movie title. Our first theorem, Theorem 1014, segments of the chords theorem. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other. So basically we have AE times EB equals DE times EC. Okay, it's a little ratio proportion that you can figure out. Let's try our first example. Find lengths using theorems 1014. So I have segments of the chord, so we're going to multiply then. And I'm just setting up one segment times another equals one segment times another. And this is what we did. You know, those two segments multiplied equals these two segments multiplied. And let's do the multiplication. Remember, we're foiling here. So we have first, outer, inner, last. Collect your like terms, x squared plus 3x plus 2. And here I'm going to distribute x squared plus 4x. I always get quite happy when I see an x squared on both sides because it just makes life easier. X equals 2. But remember, the problem says find ML and JK. ML equals x plus 2 plus x plus 1. 2 plus 2 plus 2 plus 1, 2, 4, 6 equals 7. And JK equals x plus 4. 2, 4 equals 8. There you go. All right, the next group of vocabulary and theorems, tangents and secants. This blurb here says that a secant segment, it's the whole thing, is a segment that contains a chord of the circle and has exactly one endpoint outside the circle, right there. The part of the secant segment that's outside the circle is called an external segment. Okay, secant segment touches here and there, and the tangent segment. And this theorem says if two secant segments share the same endpoint outside the circle, then the product of the lengths of one secant segment and its internal segment equals the product of the other. So basically we have EA times EB equals EC times ED. Let's try. All right, what is the value of x? So we just said we multiply the external times both of them together is equal to the external times both of them together. So 5 plus 4 is 9. 9 times 4 is 36. And then distribute this. 3x plus 9. 36 minus 9 is 27 equals 3x. X equals 9. And there we go. X equals 13. You try, push and pause. There we go. Check it out. Next. Okay, this one we're going to do together. It's a little bit confusing, so let's set the problem up. 3 times 3 plus x plus 2 equals x plus 1 times x plus 1 plus x minus 1. Crazy. Simplify. 3 times x plus 5, 3x plus 15. Here, those cancel out. I get x plus 1 times 2x, which gives me 2x squared plus 2x. Okay, I have an x squared in this problem, so I know I need to use the quadratic formula, which we'll go over. But when I use the quadratic formula, I need a 0 on one side of the equal sign and all the numbers on the other. So I'm going to subtract a 3x, and I'm going to subtract a 15. That leaves me with nothing over here. 2x squared minus x minus 15 over there. Quadratic formula, negative b plus or minus the square root b squared minus 4ac all over 2a. Let's put that in. So x equals, let's see, I have a is 2, b is negative 1, and c is 15. So negative 1 plus or minus negative 1 squared minus 4 times a times c all over 2a. Simplify, I get 1 plus or minus 1, negative 4 times 2 times negative 15 is positive 120. 1 plus or minus the square root of 121. I'm going to ignore the minus, well, hold on, 1 plus or minus 11 over 4. I can't do the minus because that would give me a negative answer, and I can't have a negative answer for x. So 12 over 4 equals 3. Whew. Oh, x equals 3. That was tough. Theorem 1016, segments and secants of tangents theorem. If a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment and its external secant equals a square. Blah, 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 blah. Square the one that doesn't have anything internal and multiply it times EC times ED. Let's try one. Okay, so you square the one that's by itself, and you multiply it, erase that, the external times the total. Okay, I would just jot these down. Let's see, what is 16 squared? My memory says 256, but I don't think that's right. Hey, it is 256. X squared plus 8x. No. 0 equals x squared plus 8x minus 256. Here we go again. Negative b plus or minus b squared minus 4 times a times c all over 2 times a. Negative 8 square root 64, a negative times a negative is a positive, 4 times 256, 1024. Add those together, 1088. Square root of that. $32.99. Let's make that 33. Over 2. Again, we have to ignore the negative. So I do the negative 8, but I don't want to do minus 33, because that would give me a negative answer. So negative 8 plus 33, divide by 2. I get 12.5. And then we check the answer in the book. And it's right. Yay! Okay, there are a ton of you tries at this point, so take your time and do every one. I'm going to push pause for everyone, but I need you to try these on your own. Here, I ignore the negative answer and get 2. Push pause, please. There we go. Next. Push pause, please. There's the answer. Let's try the next one. Push and pause. Here the instructions say determine which theorem you would use to find x, then find x. Another quadratic formula. I got 9.6, and we used theorem 1016. Okay, number 8. Push and pause. It was a nice break from the quadratic formula. X equals 8. Okay, determine which theorem, and then find x. Push and pause. Theorem 10.5, x equals 16. Skipping this one. Alright, example 4, science. Those are 3 of Saturn's moons. Each has nearly circular orbit of that many kilometers in radius. The whatever spacecraft entered Saturn's orbit in July 2004. Telesto is on a point of tangency. Find the distance dB from Cassini to Tethys. I feel like I'm reading the Old Testament. That's hilarious. All right, now what just happened and what are we trying to decide? We're trying to find distance dB. This whole distance, can't see that. I can see that better. I'm trying to find that whole distance. So I'm actually going to move that picture to the next page and work on it. So hold on a sec. All right. It's going to be with some big numbers. So we're going to use, the name of the theorem would be the, let's see, Theorem 1016. 203,000 squared equals 83,000 times 83,000 plus x, right? Because we don't know that. Oh, goodness. I would keep everything in your calculator so you don't have to write down those huge numbers. 203,000 squared. You can 4.1209 times 10 to the 10th. 83,000. One, 2, 3, 4, 5, 6, 7, 8, 9. All right. Do some solving for x. I'm going to push pause and solve for x. You guys are walking in. I'm trying to get this done. Okay. There's example 4. You have your answer. Daily homework quiz. Daily homework quiz. Another one. And you're done. Oh, wait. That's number 4. Number 5. There's a lot of them. 2 points, though. Turn them in tomorrow.